The first thing to realize when designing your application architecture is that your phone typically has a much more powerful processor and a much larger battery than your wearable. You want to offload as much as possible away from the wearable to try to get the most battery life out of it. Another key part of the application architecture is that the phone has direct access to the internet while the wearable over here does not. So let's imagine a scenario where you're building an app to show weather updates on a wearable. The phone will need to make the request to fetch the data and then send that to the wearable via the data layer API. There are many ways that you can implement this, but if you do not design this carefully, it may perform poorly. So how do we implement an efficient solution to this? One of the first improvements comes from changing how you wake up the wearable device. Rather than having the wearable wake up every 10 seconds or so and request an update of information from the phone, instead, allow the phone to drive updates to the wearable device. The simple action of keeping the watch asleep as long as possible will help conserve battery life. So once you've made the weather update request from the phone to the internet, you may get back updated information. An important step to do here is to compare this with the previous information downloaded earlier. If there's no change to the information, you should not update the watch. There's no point waking it up just to tell it that nothing has changed. We want the watch sleeping as much as possible. If you have detected a change, it's important to minimize the amount of data we actually send to the wearable. It would be a bad idea to send the entire weather query result to the wearable, since it probably includes a lot of extra information, such as what you see here. Instead, we should pass it on the phone and send just a single temperature value, like this one here, to the wearable. Remember, we're trying to minimize the amount of work done on the wearable, and even things which might seem trivial will add up eventually. So, how should we send data to the wearable? If you had to send a large amount of temperature data for a time range, it might be tempting to create separate data items for each time and temperature and send them separately. However, for each piece of data sent between the phone and the wearable, there are overheads added by the platform and the network. These overheads include headers for packets, acknowledgements per packet, and energy required for every packet sent, as well as activating the wireless hardware. When designing code to send data over a network, taking these overheads into consideration is important. So by storing many numeric values into a single message, there will be much less data sent and processed than sending each one separately. The results can be quite considerable, as you can see here. Once you have sent the data item to the wearable, you might be tempted to add an acknowledgement to check it was received. However, if you're using data items, they are guaranteed by the framework to be synchronized when the wearable is paired up, so you can be sure they will eventually be received. If you're using messages, then you will need to check that they were received, since transmission is never guaranteed if the device is disconnected or something else happens.